Right now, you are surrounded by an element you need to survive, yet every breath you take leaves your body completely unchanged. Nitrogen makes up nearly 80% of the air on this planet. It presses against your skin every second of your life, but your cells cannot absorb a single atom of it directly from the atmosphere. This is a biological dead end. Nitrogen is the central building block for your muscles, your skin, and the DNA that carries your genetic code. Without a constant supply, the internal machinery that builds your body simply cannot function. The problem is the nitrogen molecule itself, N2. Two nitrogen atoms are held together by a triple bond. These three links create a grip so tight the atoms are effectively fused. Breaking this bond requires staggering energy. It is one of the most stable and stubborn structures in the natural world. To your cells, breathing in nitrogen is like being handed a sealed steel safe containing your dinner. You can hold the safe, but you cannot get to the food inside. In ecology, this creates a limiting factor. A forest can have abundant sunlight and endless water, but if the nitrogen remains trapped in the air, the entire ecosystem will stop growing. The abundance of life on Earth is determined by molecular access. The world is effectively throttled by the chemical difficulty of opening that single N2 molecule. The only natural way to bypass this barrier is hidden in the soil beneath your feet. A single species of bacterium evolved the specific chemistry required to pull nitrogen from the air and convert it into a usable form. Inside this microbe sits a specialized biological machine, an enzyme called nitrogenase. This enzyme uses an iron-molybdenum cluster as a precision blade. It slices the triple bond, attaching hydrogen to produce digestible ammonia. But this feat comes with a massive dill. To process one nitrogen molecule, the bacterium burns 16 ATP units, the cell's energy currency. Because this reaction is so expensive, bacteria living alone in the soil often lack the fuel to run the process at full capacity. They are limited by their own high operating costs. To afford the energy needed to survive, these bacteria often seek out a permanent trade agreement with plants. This partnership is most prominent in legumes, a family of plants that includes beans, peas, and clover. When the plant detects the right bacteria, it constructs a specialized organ to house them. These are root nodules, underground factories, where the plant provides the bacteria with shelter and a steady supply of sugar in exchange for nitrogen. However, these factories have a major design constraint. The nitrogenase enzyme is destroyed the moment it comes into contact with oxygen. This presents a conflicting requirement. The bacteria must have oxygen to breathe and burn the sugar for energy, but letting too much oxygen into the nodule will ruin the enzyme. The legume manages this by producing a molecule called leghemoglobin. Leghemoglobin acts as a chemical regulator. It binds to oxygen and releases it in precise tiny amounts, enough for the bacteria to survive, but not enough to damage the nitrogen-fixing machinery. Because this molecule is nearly identical to the hemoglobin in your own blood, a sliced open legume nodule will appear stained pink or red inside. This microscopic cooperation supports the global protein supply. Every soybean and pea is the product of an underground factory powered by these microbes. For billions of years, bacteria held a total monopoly on this process. Every atom of nitrogen in the living world passed through a microbe before it reached a plant or an animal. That monopoly ended in the early 20th century. Chemists Fritz Haber and Haber-Bosch developed the way to bypass the biological requirement entirely. Their solution relied on industrial scale. By using intense heat and crushing pressure, they forced atmospheric nitrogen to react with hydrogen, creating synthetic ammonia in massive factories. This synthetic nitrogen became the fertilizer that enabled modern agriculture. It allowed food production to increase exponentially, supporting billions of people who could not have been fed by natural cycles alone. This change is reflected in your own body. Roughly 80% of the nitrogen currently in your DNA and your muscles came from one of these industrial factories, rather than a biological source. But bypassing the natural limit has consequences. Humans have doubled the amount of usable nitrogen on the planet, flooding a system that was previously kept in a tight balance. This excess nitrogen leaks into waterways. fueling algae blooms that deplete oxygen and leave entire aquatic ecosystems unable to support life. The scale of life on Earth depends on the ability to access nitrogen. For billions of years, that capability was restricted to microscopic enzymes in the soil. Today, we have moved that control to industrial machines, and the entire planet is reacting to the change.